we want to continue looking at examples of using the quadratic formula. And in our last video, we looked at using the quadratic formula where we got nice integer solutions to our quadratic. But that is not always the case. We don't always get those nice, neat integer solutions when we use our quadratic formula. So we're going to do one now where we get, instead of a nice, neat integer solution, we're going to get some rational solutions. We're going to use, again, the quadratic formula. If you have not memorized this, you need to be doing so. X is equal to opposite b plus or minus the square root of b squared minus 4ac divided by 2a. And you know how bad my singing is, but you need to memorize this. And one of the easiest ways to do that is with a song. So we're going to sing the quadratic formula here before we get started. Might help you if you remembered it. You need to all sing together. So here's my little song for the quadratic formula. X equals opposite b plus or minus square root of b squared minus 4ac divided by 2a. All right, now it sounds a little silly, but it should help you to memorize the quadratic formula. So here's our problem that we're going to use in this example. 6x squared minus 5x minus 1 equals 0. And for our example, we're going to go ahead and write down what the values are for a, b, and c. In this case, a is equal to 6, our coefficient of x squared. B is equal to negative 5, the coefficient of x. And c is equal to negative 1, the constant term. So if we go back and plug those in to our quadratic formula, x is equal to opposite b, so negative and negative 5, plus or minus the square root of b squared minus 4ac. So negative 5 squared minus 4 times 6 times negative 1. Notice this negative 5 is in parentheses when we put it into our function because the negative 5 is what is squared. All over 2 times 6, 2 times a for our quadratic. So the quadratic formula, x equals opposite b plus or minus the square root of b squared minus 4ac divided by 2a. So then we begin the process of simplifying, and when we begin the process of simplifying, we get 5 plus or minus the square root of negative 5 squared is 25, and if we multiply our negative 4 times 6 times negative 1, we get plus 24 over the quantity 12, 2 times 6. You can do this in as many or as few steps as you want to do this in, and you can type it into your calculator in order to solve it if you want to. Just be very careful. Remember that you're going to have to make sure that when you do that, you are putting it in with the proper parentheses so that you get the whole term. 5 plus or minus the square root of, and 24 plus 25 is 49, over 12, and then I am going to change that square root of 49 into 7, and when I do that, that will give me 5 plus or minus 7 over 12. So now I've got two solutions to this problem, so let's write them both separately. I have 5 plus 7 over 12, which is 12 over 12. 12 over 12 is equal to 1. That gives me an x-intercept of 1, 0. So my first solution here is the quantity 1, 0. The second solution is going to be given by 5 minus 7 over 12. I have to take into account that that was a plus or a minus, and therefore it could have been either solution. And when I do 5 minus 7, I get negative 2. And so negative 2 over 12 simplifies to negative 1 over 6. My next solution then is therefore negative 1 over 6, 0. And just like we talked about with the radicals, it is generally not a good idea to change those to decimal approximations. You want to leave those as exact answers in your problem. So the exact answer for this one would be negative 1 over 6, 0, and not some approximate decimal quantity. All right, quadratic formula. Wonderful way to solve lots of quadratics. If you have not memorized it yet, you need to memorize the quadratic formula, and you may want to memorize the song that goes along with it to make it a little bit easier for you to memorize.